Okay, now in this session we are going to, in last session we have seen servo motor. Now in this session we are going to see a way to drive the simple DC motors. So you can use transistors also, you can use relays also, but we are going to use one specific IC for that. I'm going to keep the circuit aside for the time being. Now on our hardware we are having this IC. Okay, so here we are having one IC. Its name is L293d. It is a motor driver IC. It can drive two motors in different directions at a time. Okay, so we are going to see how to design circuit for this and how it works. So let's jump to the Proteus. So from components, we have to select L293. So here I am going to show you both the ICs. Here you can see one more IC is there, which is having name 298. Okay, its work is little bit similar to the 293D, but it supports higher amperes. Okay, and we need a little bit supporting circuit for this. Okay, so its circuit is little bit complex than L293D. So we are going to use L293D. So let's put this IC here. Now, here we can see multiple pins. So some are self-defined, self-explainable. That is in one, in two, out one, out two. So this in one, in two is for this out one, out two. Okay, first motor. In three, in four is for second motor. That is out three, out four. So let's do the wiring here. So for that we are going to need a motor. So write motor. You can see a simple DC motor. There are multiple options. We are going to select this active one. Let's place first motor over here, second here. Let's okay, better. It's better to rotate them. Okay. Now let's connect this to pin number three. So this is our motor one. This is our motor two. Okay. Let's first, most important thing, let's provide the ground first to this IC. So this ground terminal. Okay, so here we have to provide some input. For that, we are going to select one simple digital input, that is logic toggle. So this is our logic toggle. So we are going to provide it to the in one, in two, or in three, and or in four. Okay, now remaining pin. This pin enable one. It enables the input when it is high. Okay, so why we need this? We can directly put signals over it and the motor will run. Okay, sometimes there are chances that we are going to connect this input pins to any other device also, means we are doing the multiplexing. Okay, in that case we might share these pins. So for that case we can enable and disable that pins. Now we are going to short these. So we are going to short these and we are going to connect it. We have to provide 5 volt supply to these to enable them. So what we are going to do, we are simply going to short all three of these. Now here we can see two power supplies. Okay, so first one is, this one is 5 volts to drive the IC. Okay, so first supply will be just of 5 volts. So this is required to drive the IC itself. Next one is to drive the motor. Okay, so now why we need this IC? So your STM32 can provide only 3.3 volts and very small amount of current. Yes, but These motors need around 12 volts of supply at minimum, and depending on motor, it can drive from 100 milliamps to 2 3 amperes also. Okay, so in that case, we cannot drive a motor, DC motor, 12 volt DC motor from microcontroller itself. So to drive that motor, we need this driver circuit. Okay, so it will take 12 volts. Okay, whenever we are going to do any pin high, it is going to send this 12 volt supply to the respective pin. So let's simulate this. Let me check. We have got 5 volt over here. Okay, no issues at all. Now if I click this, okay, just a second. Let me delete this for a while. Okay. Now, okay, let's simulate this. So if I press switch one, first motor is running clockwise. If I press this, first motor is going to run anti-clockwise. If I press this, second motor runs clockwise, and at this signal, second motor is going to run anti-clockwise. So this is very simple. If you want to make a four-wheeled robot, okay, four-wheel drive, okay, in that case, what you can do, you can connect these motors parallelly. Let me stop the simulation. This first pin goes over here, second pin goes over here. This can be used for your four-wheel drive robot. Yes. Now, how you can drive this robot? So whenever your all four wheels are running in forward direction, robot will run forward. Okay. In second case, if both of your motors are running in reverse direction, your robot is going reverse. Okay. Now there is slight change for your turning. Let me turn these off. Now if I make this run forward and let's keep this stationary, your robot is going to turn right side. Okay, I'm going to make them steady and I'm going to run these forward. In that case, your robot is going to turn towards left. Okay, if I make something like this, now it is running forward and upper motor are running in reverse. In this case, the robot will take zero turn on the spot. Okay, so like this you can configure your robot accordingly. Yes. Now the advantage of these motors are it can handle 300 milliamps per channel. Okay, in total it can drive four motors up to 1.2 ampere. This whole IC can handle, not more than that. Okay, yes, and you can add heat sink also to this. Okay, if you want for higher currents. Okay, 1.2 ampere it can handle. That is 600 milliamperes each channel. That is 300 milliamps for each motor. So in this session, we are going to do the interfacing of this. So this is very popular IC actually. So you can use it in your projects also.